Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com, and this is the portable Pico Pal. This is the Raspberry Pi Pico, which is one of the neatest microcontrollers ever to hit the market. It's very new, and I decided to create an expansion board for it with a battery backup on the back that's removable via Velcro. Each set will come with Velcro that you can glue to the back and allow for you to keep that battery backup on there. It plugs in right here. There's an on-off switch, and it takes 3 AA batteries. And so you can have both USB plugged in and the battery backup going, and you can remove USB whenever you want, and the battery backup will take over. USB provides a slightly higher voltage than the battery backup, so if you have the battery backup on and you're plugging in USB, the battery backup will not deplete. It will just kind of stay still, and it will only consume power when you remove USB. In any case, let's talk about the hardware. We've got all of the GPIO lines accessible. We've got a buzzer, 2 LEDs, a plug-in PIR sensor that can be removed at any time, a DS3231 real-time clock, precision real-time clock, and that's located actually underneath the plug-in for the Pico. We got 2 single-pull, single-throw buttons, a heart rate sensor that plugs in right here, which allows for us to monitor our heart rate. We've got a little buddy talker chip on here, which has 254 sound bytes, and we can take that audio and control it with the Pico and plug in an external set of powered speakers to add voice to our Raspberry Pico. We've also got a light sensor, a microphone, a 4-channel dip switch, and I'm pretty sure that's it. So, from a hardware perspective, that's it. I'll be creating several other videos and many pieces of commented code for the Raspberry Pi Pico, the portable Pico Pal, because, again, this is more of an educational tool. Well, the Sleep Keeper, the older brother of the portable Pico Pal, was designed more as a data logger, whereas this one, I designed it because I really want to get into MicroPython. I've played with the Raspberry Pi before. MicroPython is a little bit different than normal Python, Python 3, but again, I'm still learning, so I wanted for you to come on an adventure with me with this little board. It really adds a heck of a lot. Every Pico Pal comes with either a heart rate clip or a Velcro strap that goes around the sensor circuit board that can adhere to the size of your finger. With the included stereo cable, connect one side to the audio output and the other end to a set of powered speakers to bring voice to your Raspberry Pi Pico. And if you would like to, you can remove the PIR sensor and use the connector on the top to provide 5 volts and ground to an external circuit, and this can be used as either an output or an input, keeping in mind that if you're using it as an input to the GPIO lines, that the input cannot exceed 3.3 volts. I've got Thonny open with my program entered, and I've got it connected to the Raspberry Pico on the portable Pico Pal. I've got a set of powered speakers just from the dollar store plugged into my audio output. I've got my heart rate sensor right here. As you can see, there's a little light bulb, little LED rather, in there. I'll fit my finger on it. And what I'm going to do is I'm going to show you the diagnostic program that I wrote. First, I'm going to show you the feedback on the shell of Thonny, and then I'll show you the how the board looks when everything's executing. So this tests every single peripheral on the board, every single electronic block. So let's have a look. I got my heart rate sensor on my finger. I'm going to run the program. You can only see a little bit of my code at the top. I've enlarged the shell, which will give us more room for feedback from the Pico Pal. I'll run the program, and it'll test everything. It just played one audio byte, color. It sampled the light in the room and converted it into voltage, which was 3.3 volts. Sampled the microphone with 0 volts because there was not a lot of sound. And right now it's waiting for a really loud noise, which I'll provide right now by either clapping or hitting the table. Checks all of the status of the dip switches, which ones are on, which ones are off. Now the LED on the main board is, one of the 2 LEDs is blinking according to my heart rate. You can't see that, but I'll show you in a minute. And it will end when I press the SW2 button. And now what's going to do is it's going to start profiling my heart and my heart rate. It's going to give us the BPM every 10 seconds. It's going to average my BPM. I expect it to be quite high because I'm kind of excited right now. But as I stand here, or if I'm sitting down, it's going to go down and down and down. So right now it's at 88. The more calm I am, the more it goes down. Yeah, it's going up right now. Yesterday when I was sitting down and running this test initially, it sat at about 68 BPM. how much sleep you've got, how well you're eating. The average heart rate should be between 60 and 100. The lower the better. An athlete should see around 40 to 60. And right now mine is sitting between 80 and 90. So again, on a good day, you'll see between 60 and 80. And I didn't sleep so well last night, so I expect it to be a little bit higher. But in any case, I can end this profiling by pressing the SW1 button.
Color.
And the program resets. So everything has been tested. I actually should have added in a 5-second delay there. If you actually look at this piece of code, it says the code will loop again in 5 seconds, but I forgot to add that delay in, but I'll do that next time. Anyway, this is just the beginning of the program. It's now waiting for another loud sound, and I'm going to unplug it before it beeps again. And I'll show you my code, which will again be provided to everybody. All of the projects will be fully commented, and you'll be able to view them on the project page. But we've got a nice long piece of programming here. Most of it's commented. All of it will be commented when I'm done. And this is, again, used as an educational tool just for you guys pledging towards the Kickstarter. I forgot to show you I wanted to show you the board while this diagnostic test was going on.
Color.
So it plays that sound bite. Everything's being read on the board. It's waiting for a loud sound. Now it's reading my heart rate, and you can see it representative on the LED. I'll end that program by pressing SW1, and now it's profiling my heart rate. And while it doesn't look much different, that is what is happening. So as you can see, we only saw one dip switch on, or off rather, and that would be dip switch B when we were looking at our shell in Thonny. So not a lot to see from the board. Most of it is on the feedback in the Thonny shell, but I still wanted to show it to you. So for the second time, thank you so much. I enjoyed making this video. I hope you enjoyed watching it. Check out the Kickstarter, link below.